Welcome everyone, this is Daniel Paez and I'm gonna demonstrate how to do few processes in QGIS for planning. So the first thing I'm gonna do is to create a new project. On the top left corner, I click on the little new document. It asks me if I want to save the things before. There were some temporal documents. I say yes. And now when I have an empty new project, you can see at the top it says untitled project. The second thing I'm going to do is to select the coordinate system. In this case, I'm going to work in Victoria. So I'm going to use GDA 2020 VGrid because it's projected. I want to measure in meters. There's options for New South Wales, for South Australia, and so on, as you can see on the screen. I'm going to say OK. Now that the project has the right coordinate system, I'm going to create the GeoPackage that is going to carry the whole project. This is a good practice for a workflow in QGIS. So I go right click, create database, not connect. Connect will be if you have or given an existing GeoPackage. I'm going to put it in the folder data. And I need to give it a name. And remember always to click in the three dots so you get the opportunity to locate where to put it. And I'm going to say no geometry type to create the GeoPackage empty. And it has just a no geometry table added to it. So an element needs to be added. And the next thing I'm going to do is save my project file into that GeoPackage. So if I go to project, save to GeoPackage, and I now need to select the right GeoPackage. The one that I created is the demo June 2025 VIC, and I need to give it a name before I can save it. So I'm going to give it a name now, and you can give it any name, but this is the name to the project file, not the GeoPackage. And you will see that once I save the QGIS project in the GeoPackage, everywhere I move it, it carries that particular file. So I can see here the demo VIC, that is the one I have created. I have multiples in my computers, multiple GeoPackage, and I can see now the project file of QGIS, the colors, the symbology, the layouts, everything that you save in the project will be saved with the GeoPackage. So when you move it, you're always going to have it and being able to do it. Now, we're going to add data from an online server of the government of Victoria. And if you go to data.vic.gov.au, you can download the data. And what you need is the WFS URL. And you can see here on the screen, I copied that URL to be able to create a connection and being able to access the data live from the server of Victoria. Then I'm going to go to layer, and add WFS layer, and at the top there is a new server connection. I'm going to create a new server connection. I need to give it a name. I'm going to give a name for that particular connection, and the URL is the URL given by data.vic.gov.au or data.newsouthwales or data.sa.gov.au, whatever state you are. But remember that XML link that has that, you need that to be able to do it. And I go back to the connection and say, okay, nothing happens, but I need to select the connection and go connect. And then all the layers that are in that server live, you need to be connected to the internet, allows you to get live the latest version, iterative version for the state of Victoria. So you can see here, I'm scrolling down to all the different server information. If you need the metadata, go back to the website and I'll give you all the metadata relevant to the particular ones. One of key aspect here, the license is Creative Commons Attribute 4.0 International, so that give you a lot of flexibility to use it, even for commercial purposes, for projects and so on. But if you need more information about the metadata, the fields and everything, you need to go back to the original source. Now, I'm going to do a demonstration with a few layers. So I'm going to select the layers that I'm going to use. So I'm scrolling here to look to the different layers. And there's a lot of possible layers. I can see here that what I want to do is the plan. So I'm typing in the search at the top and I can search the different areas. And I'm going to use this one that is called plan zones. That's the planning zones for the state of Victoria. And with that selected, at the bottom, lower right corner of the bottom of the page, when you select it, you can actually add that to your map. So with add, that gets added to your map. And you can add as many as you want. I mean, at this stage, I'm adding the whole planning zone of the state of Victoria. It's quite a large data set, so I can abort not the adding, but the downloading of the whole features. So if I abort this, I'm not aborting the adding, I'm just aborting the rendering of all the features because there were too many of them that probably add on it. So I'm gonna abort that and close, but you can see the figures were added. And now you have there's a zoom tool. I'm gonna zoom to the specific area of my project. I might have a file that tells me where the area is and so on. I'm gonna do a little bit of just guessing where I need to go. And automatically it will go and load again. So I'm here much more in the center of the state where I'm going to plan to work. And I can see now in purple all the planning zones. They all look in the same color because I haven't sent the symbology, but allows me to see all the planning zones that are in that particular area. Now, a key thing important here is if you don't want render and waiting for this and so on, you can always make it the layer non-visible by clicking on the layer style, and that allows you to stop that rendering and so on. I'm going to zoom to a more specific because I don't want to work in a very big area for this particular exercise. So I'm just focusing on a specific area, and I just want to do an example that is relevant for all of us. Now that when I'm zooming, I'm going to go back and add more layers from the same server. So I already connected. I don't need to reconnect. Look at it's the same connection that I did before. And I'm looking now for data related to transport. But look, scroll down and you will see many data. If you need to know which data is, when was later updated and so on, you need to go back to data.gov.vic.au to review the metadata, and I will give you the information and so on. The more you use the data, the more is given. The state of Victoria put all the layers or many layers in one server. New South Wales have more broken servers, one for transport, one for planning, one for environmental aspects and so on. But you can see here, the state of Victoria has a lot of layers that are live layers that you can do it and so on. I'm going to select TR-rail, which is the rail lines, and this analysis is about the sound that rails produces and which areas is impacted in. So we want to know which areas are impacted by the noise produced, and the sound contamination, the noise contamination produced by the rail in this particular area of the city of Melbourne in Victoria. Now, having that, I have two layers. I have one is a line layer. You can see it. It's lines in the little description, and I can see the lines in front of me. And the other one is polygons, which is the zones for the particular ones. And I want to know which areas are nearby in terms of planning zones, and what are affected. I will be using few of those tools to be able to analyze that particular case. Okay, with that information, let's move to the next part, which is being able to understand the changes and the areas of influence. One of the things is important is always savings, and I'm going to cut some of the data sets that I'm in the server to my specific study area. If you can imagine, you have the whole of the state here in this layer, so I'm cutting it by selecting first. I use the selection tool, select by polygon. You press normal click with the specific one, and you can then go right click on the property, select save as selected features, and I'm going to save it as a shapefile, just temporary. You will see how I can put them on the thing. But always remember to press in the three dots so you actually know where you're saving. I'm going to put in this folder that I call data. I give it a name, and it's the rail selected, and say OK. So the rail, this is a new rail selected, and you can see it there. And just by dragging and dropping it to my database that I created, the GeoPackage that I created, automatically gets saved in that package. And when I move that package or send it to someone, I can use it. And I'll put a link in the description if people want to play with the same GeoPackage that was created. With that, also you can see here, I have still the connection to the big one, but I'm going to do a selection now on the polygons. Look at the polygons of the land use planning is the one that I selected, and that's the one that I'm using. So I got them in yellow, the selected one, and I do the same export, save as, selected ones, 3 dots, give it a name, and I'm going to be selected planning zones because are the ones that I'm using a subset from the server. I don't want to use the whole state of Victoria to do this analysis. It will take too long and it's not the purpose. Most of projects will have a study area. In this case, the study area is what I can see on the screen. Now, new layer is created. Now it comes in brown. Now it's important to understand that you need to move things to your GeoPackage if you want to use them, have them in one place later on. And once you move them, you are welcome to delete them, transfer them, and so on. And you always can bring them back. So have a look. And here, if I right-click on the layer, I can duplicate it if I want to do something, or I can select multiple ones and say layer remove, and I remove one, and I can remove the other one here. Again, you can see here the different options and remove. While I'm removing it, I don't need those statewide layers from the server. Will make my analysis slow. And always remember to save. It's important. That's why I always click on the save. You know your project is safe because there's not a little star at the start of the name on the top of the window. With that, now I have the data that I need, and it's for the study area only, which is what's selected using the selected tool here. Remember, this is the selected by polygon. And it gives me that information, and now I can zoom out. You guys can see I can zoom out, and I noticed that some polygons were selected outside the area. And this is typical because in some of the road reservation, for example, which are a type of planning zones, are beyond the area. And when you select a part, or you touch a part of that polygon, the whole polygon gets selected. If you want to cut it to a specific shape, for example, a local government or a study area, a postcode and so on, you will have to do clip and clip the data so it gets cut to the specific study area and only that specific area. All right, we got that, and that information is the one that I'm going to use for processing the analysis. Remember, I'm going to do an analysis that tell me what are the planning zones that are within a distance that are affected by the rail lines, by the actual rail, not just the stations, but the whole rail, because that's where the trains go up and down. To do that, I'm going to use a few tools, and there will be few ways to access that tools, and I'm going to be showing you those tools, and requires remembering that the tools will have different options. But if I go to vector geoprocessing, the first one that I'm going to use is buffer, or you can just type on the panel on the right buffer. And buffer is areas of influence. So you will have the ability to see areas of influence. I can see here, look, it is doing the calculations in meters because this coordinate system is appropriate. The data is in the right coordinate systems. If it was not, you will get a warning, and you need to be mindful of this and make sure you have selected the first coordinate system and you transfer the data to the right coordinate system. It's called reprojecting if that is required. Let's type the distance of influence. What will be the distance affecting the noise, is whatever the analysis you're doing, but I'm going to do it on the rail. So the input layer is the rail, and in distance, I'm going to put what is the area of influence of that, which is important. Is 800 meters in this case, could be whatever the planner or analyst is doing. That's perfect. And with that, I'm going to dissolve, which becomes very important. I'm going to dissolve because I want the production to be only one polygon and not multiple polygons. And that's important to understand. With that, I'm going to ensure the analysis is right. The rail is the one that I'm selecting. The distance is 800 meters. And create an area of influence, a buffer around the rail in my map. So let's close after that. And I see a new layer created, buffer. And I'm going to look at the attribute table, and the attribute tell me that was properly dissolved, because when you dissolve, you only get one polygon that is all the area of influence that is within 800 meters of the line feature that you use in this case was rail. And something important to notice, look, there's a little symbol next to my buffer. That means it's a temporary file. It hasn't been saved somewhere. It's somewhere temporary saved. I could have saved it directly and do something. And being able to analyze it. And with that, it becomes important to understand that the buffer tool I can change it and show you a difference if I don't dissolve. Look, if I click in recently used, I can see the tool that I have used, but here in history, I actually can replicate and return to the analysis I did. And I'm gonna double click on the analysis and I can see what I did before, the parameters that I put 800 meters and so on. And just to demonstrate, you can change the parameters and run it again. Remember, this is in history. Look at here, processing tool, history, click here, history, and then you can see that buffer, I'm going to not dissolve it and run the tool again. Doesn't change the previous analysis, creates a new buffer. Have a look here now. The new buffer shows you there are multiple polygons because every segment of the rail gets affected. Every segment of the rail gets an 800-meter buffer, and that's why it looks very different. And I get many polygons, which is not the case that I want. I want just one polygon that tells me what are the areas that are within 800 meters of a particular feature. Typical analysis of walkability, noise impact, contamination, fire, whatever. All those areas of influence you will do dissolve. In very few cases, you actually will use something that is not dissolve. Most cases you need to dissolve. Now let me rename the file so we can actually put it renamed in our saved. So I'm going to call it buffer 800 meters rail. So remember what it is. And I'm going to simply save it in my package, GeoPackage, by doing the same as I did before. So it's temporary at the moment. Have a look at the little symbol on the right of the layer. And I'm going to drag and drop it to be able to save it in my GeoPackage. The GeoPackage that I'm using is called Demo June 2023-Vic. Again, if people want to play with it and see what was the result, I have provided a link on the description. So that becomes the first part of the analysis is the areas in the map that are actually covered. But what I want to analyze is the areas that are which planning zones are affected by these 800 meters. And in particular, I'm interested in analyzing what's going on with residential in this area. So this analysis is about the impact of the rail on residential, which is more significant in terms of noise contamination compared to the analysis that you will do with other aspects. But in industrial areas, the noise contamination by a rail is less of an impact compared to rail, which use it more. So let's work with this one. I'm going to open the attribute table and I'm going to select the residential. Click here in the final looking tool, the filter, and this tool allows you to select by the parameters. And in this particular case, I know I'm looking for residential, and the residential that the message for my case is schedules 1, 2, and 3. So I'm going to show you how schedules are selected. So I tap a little bit of the name and I can just click on it, and I'm going to at the bottom do select features, and I can see 53 were selected at the top. Look at the top of my window, and with that I can actually see the selection. But I want to now do a schedule 2, the 2 type of residential. But look at the little arrow I'm using. I'm going to add to the current selection. Now there are 65. So I added, no selected, because otherwise I will overwrite and lose the previous selection. And I also need residential 3. Let's do it again. I come here, schedule 3. I select it. And again, I go back, little arrow, add to the current selection. That gives me 79 selected features. That sounds good. I can, I can have the possibility to see that selection both in the table or in the map in QGIS, which is important to do it. If I click at the bottom, I can see here, I can see it as a table or as a list. And the yellow ones in the map and the blue ones on the table are the ones that have been selected. So let's have a look. You can actually see them, the yellow ones in the map that are those selected. Now, always to save your selection, there are multiple options, but the best one is to export it. Go save selected feature as. Click that and do the same process as before. Remember, you have to always click on the 3 dots. No, I'm going to save it as residential 1, 2, 3 analysis area. And I'm going to click in the 3 dots to tell the computer where to save it. And I'm going to use this folder called data and save. and say, okay, so a new layer is created. I'm going to add it to my GeoPackage so I know it's safe and I'm not going to lose it. I realize I haven't added, no, the buffer is still is a temporary, and I'm going to distinguish it a little bit different. So I can click on the corner, so symbology, and add a little bit of opacity. So allows me to see behind the layer, and just want to make sure what's happening here. Okay, so what do I want? I want the pink areas that are covered by the purple buffer, which represent noise, to be selected. And remember, in this, before I can do it, I need the area. I'm going to calculate the area for every of those polygons. So I click here in the Abacus looking tool and create a new field, a new column on the table. I'm going to call it area in square meters, and to using the geometry areas, I double click in the one that says the symbol area, and that one allows me to create a new area and calculate the area for every of the polygons. Look that I'm only using the calculate area on the R123 analysis area because it's the ones that I want. So that was how I created the areas, the original areas of those polygons, because in a moment, partially, some of those polygons will be cutted and some of the areas will be inside and outside, and I want to know more precision in terms of area, what is covered. With that in mind, let me remove this one, make it not visible, not remove it yet, but I want to see, look, I want to specifically capture those polygons that are pink that are covered by the buffer. So some of the polygons will be cutted. The percentage of the area will be important to know if it's 50% or 3% or whatever it is, so I can know what percentage of residential 1, 2, 3, schedule 1, 2, 3 in this study area are actually covered by this analysis. Now, the other tool we're going to use is Clip. Remember, Clip is a tool that allows me to find the intersection between two layers, and the input layer is the layer that I want the result. I call it like, it's kind of cookie cutting, no? It's like the dough is the input layer, so it's the cookie that you want to eat, or the result you want, and the overlay layer is the cutter. The cookie cutter is the overlay layer. So the input, the result I want it to be the residential 1, 2, 3. That's wanted to do it. I want to cut with the buffer, which is the area of influence around the train station. Let's run this and my expectation. Always before running, think what is the expectation you want to see. It runs very quickly, all good. It's not a lot of data here. And with that information, I'm expecting to see the polygons being cutted based on the influence area. And a new layer, which is now lighter pink, is created called Clipped, and I can see it cut it precisely the areas that I wanted. I'm going to turn off the previews, and you can see how the areas that are affected by the 800 meters distance from the rail are clearly identified. This is residential 1, 2, 3 areas that were selected in the previous space. Let's do another calculations on the clip areas and go to the attribute table, and I'm going to create a new calculation of the area. Look how I do it. Abacus looking tool. The original area was area meters, and I'm going to set clipped area. And it is in square meters, and I go again to geometry, and I'm going to select the same area with the dollar symbol in front, say OK. And I got a new calculations, and I can see that many of them are completely within the polygon, so it's 100% within, and others are not. But to get a precise calculation, I'm going to create new field called percentage that is within the clip, and or percentage that is in the buffer. I'm going to say decimal because it's going to be a decimal that tells me if 100% is the whole was inside or not. And I'm going to do a calculation which is change area or clipped area, sorry, divided by original area. Now I can see a field that gives me a percentage, 11% and so on. No, 1 is 100%, 0.006 is 6%. With that information, now I have concluded, I got the information on which residential areas we cover, and I can map it, I can change it, I can do an analysis, whatever I need to do it, and present what is the total area, residential 1, 2, 3, that is affected by this particular area rail lines. Thank you for watching, and we'll see you around.